Hey guys, in this video we are looking at our next transformation of a graph, and that is reflections. So, reflections and structures come from really doing the same sort of thing. We multiply the function or the x inside of the function by a number. Now when we are reflecting, this number is simply -1. So we're looking at reflections first because they are easier than structures, and also when we're stretching we might be multiplying by a negative number that isn't -1, so we will be reflecting and stretching. So it makes sense to be confident with reflecting before we do that. So there are two types of reflection. If we were to multiply a function by -1, so we would get y equals minus f of x. This is a reflection in the x-axis. So our whole function, our graph, just reflects through the x-axis. Or if we had y equals f of minus x, then this is a reflection through the y-axis. So the y-axis is our mirror line. So now we're going to take a look at some examples with reflections of quadratics, cubics, and reciprocals. So first up, here we have the graph of f of x equals, cut it off the side here, x squared minus 8x plus 12. Now you might be told the function, you might not be, but what you will be told or shown is important parts of the graph. So here we have a y-intercept of 12, two x-intercepts of 2 and 6, and also the coordinates of the minimum point of the graph. So part A here asks us to sketch y equals minus f of x. So minus f of x is a reflection in the x-axis. So that is going to look something like that. So what we then need to do is label the important parts. So the y-intercept now, instead of being 12 above the x-axis, it's now going to be 12 below. So the y-intercept is now minus 12. The x-intercepts are the same. So this guy is still 2. This guy is still 6. Now the coordinates of our minimum, well, it's now a maximum. So it's going to have exactly the same x-coordinate. So it's going to be 4. And the y value now, well, the minimum was 4 below the x-axis, so the maximum is now going to be 4 above the x-axis. So our maximum is at 4, 4. Now, just for a bit of bonus information, as this was y equals minus f of x, this is the graph of minus x squared plus 8x minus 12. Like that. Okay, that's our first reflection. Okay, then for part B we're going to sketch y equals f of minus x. So f of minus x is a reflection in the y-axis. So what's going to happen here, we're going to have the same y-intercept, but our x-intercepts are going to be mirrored. So 2 is going to go to minus 2, and 6 is going to go to minus 6. And also, our minimum is also going to be reflected. So, our sketch will look something like this. So, if we label the points, we're going to have exactly the same y-intercept. So, that's still 12. This x-intercept is going to be minus 2 this time. And this guy that was 6 is going to be minus 6. Now the minimum is going to have exactly the same y coordinate, but the x coordinate has been mirrored. So instead of 4, it's now minus 4. So the minimum has coordinates minus 4, minus 4, like that. So that's our graph of y equals f of minus x. Good times. Let's look at a cubic. Okay, so here's a cubic. We can tell it's a cubic. We've got 3 x-intercepts. It's sort of an S-shaped curve. So it's definitely a cubic. Now then, we've got 3 x-intercepts, minus 4, 1 and 5. We have a y-intercept of 4. We have a maximum at minus 1, 5. And we have a minimum at 4, minus 10. So, for part A, we're going to sketch y equals minus f of x. So minus f of x again is a reflection in the x-axis. So, where this graph is positive, the reflection is going to be negative. Where this graph is negative, the reflection is going to be positive. So, we're going to have the same x-intercepts. The coordinates or the y-coordinates of the maximum and the minimum are going to change, and the y-intercept is going to change. So the graph would look something like this. Now remember, drawing is not my strength, so I apologise. So, first of all then, the x-intercepts are the same. So this is still minus 4. This is still 1, and this guy over here is still 5. This guy that is now a maximum has the same x coordinate as this minimum, so it's still 4, but the y coordinate is now going to be 10 above instead of 10 below. So this is 4, positive 10. Now our y-intercept will have been reflected from 4 to minus 4. And then what was our maximum, minus 1, 5, is now a minimum at minus 1, minus 5. So that is how graph of y equals minus f of x looks for this cubic. Okay then, for part B we're going to sketch y equals f of minus x. So this time we are reflecting in the y-axis. So the y-intercept stays the same. The y-coordinates of the maximum and the minimum change. It's x-coordinates that change this time. So what's going to happen then, our intercepts, instead of being at minus 4, 1 and 5, they are going to be at minus 5, minus 1 and positive 4. So the graph is going to look something like this. Okay, so let's go through and label. So the x-intercept over here is now going to be positive 4. So that's the minus 4 one reflected. This maximum, we know the y-coordinate is still going to be 5, but the x-coordinate, instead of being 1 to the left of the y-axis, it's now going to be 1 to the right. So the coordinates of this guy are going to be 1, 5. The y-intercept is still 4. This first x-intercept on the left is the reflection of the 1 through positive 1. So it's minus 1. And then this guy over here is going to be minus 5. And then the minimum is a reflection of 4. So it's going to be minus 4 minus 10. So there's a reflection of our cubic through the y-axis. Again, Apologies for the drawing, it's not my strength. Okay, now we're going to look at reciprocals. Okay, so this time y equals f of x is a reciprocal graph. Here he is. So we have asymptotes at x equals 2 and y equals minus 1. We have an x-intercept at 3, although it seems to have disappeared. Good times. So we're going to be reflecting this guy. So, first of all then, we want to sketch y equals minus f of x. So again, minus f of x is a reflection in the x-axis. So our vertical asymptote, x equals 2, is not going to change. So you can say that what is going to change though is our horizontal asymptote, y equals minus 1. So that is going to reflect through the x-axis to y equals positive 1. So that's the first thing. I'm going to put on this sketch. So let's just dash it to show that it's an asymptote. Okay, so we still have that same vertical asymptote, x equals 2, so that is unchanged. So what's going to happen now then is our graph is going to be something like this. So it's going to have the same x-intercept, and the y-intercept is going to be reflected up. So the y-intercept is now going to be 3/2, whereas it was minus 3/2, and the x-intercept is still going to be positive 3, like that. So there is our reflected reciprocal y equals minus f of x. Okay, and finally we want to sketch y equals f of minus x here. So, this is a reflection in the y-axis, so this time our horizontal asymptote doesn't change, but our vertical one does. So x equals 2 is going to go to x equals minus 2. So again, let's just dash it to show that it's an asymptote. Okay. And we'll also put the equation in for good measure. So the asymptotes now are x equals minus 2 and y equals minus 1. So, what's going to happen this time then is, remember the graph is being reflected in the y-axis, so it's going to look something like this. So our y-intercept stays exactly the same down here at minus 3/2, and the x-intercept has been reflected from positive 3 over to minus 3. So, there it is. Hope that's right for you guys. We'll see more examples of reflections combined with stretches in the next video or the next couple. I sense it might take quite a bit of time to do and do well. So, take care guys.